Test, test. Okay, this is on. Yeah, good afternoon. Well, good morning, I guess, still 12:20. Yeah, good morning, everyone. Yeah, come in and yeah, so my name's Yan, and I've been I'm not particularly clever. I've just been doing AWS for a very, very long time. So, you build up knowledge over time and all. So I've been doing stuff on AWS since about 2010. Back then, AWS looks very different. And yeah, nowadays, well, I guess since about 2016, I pretty much entirely focus on the serverless. And nowadays, I spend about half my time working with Lumigo, which I think is still the best observability platform for microservices and for event-driven architectures, especially if most of your workload is serverless. And the other half of my time, I work as an independent consultant, where I help other companies adopt serverless and help them, find better efficiency and build things better. And one of the things that I should really enjoy doing as I'm doing consulting work and just reading every day is I like to pick up and collect the tips on how to save money on AWS. And so today I'm going to show you quite a few of the ones that I've picked up along the way. And I hope you enjoy drinking from the fire hose, because here we go. You're going to start nice and easy with a very basic one, which is billing alarms. So a very common mistake that newcomers to AWS don't think about doing is setting up billing alarms as the first thing you do, which you absolutely should. Everybody, doesn't matter what level you are in terms of using AWS, you should use billing alarms. And they're not perfect. They're usually maybe about 8 hours behind real time, but it's better to know that you've got a problem a few hours late than a few weeks late when you got the bill, because the impact could be much, much higher. So Luke, who's around somewhere today, he actually posted this sort of thread a little while back about a real-life incident they had at PostNL, where they made a one-liner change to one function, which suddenly they caused the cost to spiral out of control, and they got the alarm when it hit about 2,000, which is where they set their threshold. And this was basically a one-liner change that basically broke their caching, so that on every single Lambda invocation, they were calling secret manager, which charges you, I think, 5 or 10 cents per 10,000 requests. And if you're PostNL, you're doing millions and millions of invocations, that can go up pretty quickly. So they found out about this problem a few days, I think maybe like 2 weeks after it happened, and they were to fix it quickly. And so yeah, the fact that they found out when it's a 2,000 as opposed to 4,000, if they had waited another couple of weeks later, when the bill actually came through to your accounting, and someone comes down from accounting and goes, guys, why is your bill this month suddenly went up to $5,000? So the takeaway there is that billing alarms, not perfect, but they do work, and you should absolutely have them. Moving on to something that I think a lot of you will probably feel this particular pain point, because for most people, I think for vast majority of people I've spoken with, their experience with observability is both expensive but also bad, which I assume that's how many of you feel about London, which I can kind of understand, because I actually moved the whole country to a different country to get away from that. But having said that, CloudWatch is probably the #1 culprit when it comes to this outrageous cost on the spending on observability relative to your application. This is probably especially true when you're working with something like Lambda and an API gateway, where your costs in most situations are probably not going to be outrageous, but you may often find that CloudWatch is going to cost you a lot more than your actual application itself. And it gets worse, because the more you log, the more you collect, the less value you're actually going to get, because that just means that you've got a bigger and bigger haystack to find that needle when something does go wrong. So there are a couple of things you can do to help keep your CloudWatch logs costs under control. And one thing to do would be to make sure that you're writing structured logs, which on the face of it, you might say, well, that means every single log message I'm writing is much bigger. That's more data. That's more expensive. But when you're writing your logs, you also want to pay really close attention to, okay, what level is this log message should be logged as? Is it a debug message that happens all the time but low value? Is it an info message that tells about some general thing that happens in the system, like, oh, application is starting up, or we just initialize some cache to the client? Or if it's a warning, so there's an error, but it's not fatal, we can continue with this error, then it's a warning. Or if it's an exception, we have to just blow out at this point and return a 500, then log it as an error. And then in production, once you've carefully considered every single message you write, every single log message you write, you can set a reasonable throughput, threshold to say, okay, in production, we don't need all of those millions and millions lines of debug logs because they don't really add a lot of value. So we set our minimum log level to info. But you may say, well, that means when there's a problem, you don't have any debug logs. You have to go back and enable debug logging, redeploy, wait like half an hour for the error to come up again, and then check your logs, and then change debug logs back, and then and redeploy. And that's why also in production, instead of logging everything or nothing at all, you want to sample your debug logs for typically, say, 5 to 10% of your actual user requests, so that, well, the more user requests you have, the less percentage you need. The idea here is that you've got enough of your sample debug logs that covers every single code path you have, such that when there is a problem, you have enough of debug logs to help you figure out what the problem is, but you're not paying the full amount for all the debug logs from your system. Another thing that many people forget is that, well, it's all well and good. You limit the amount of data you actually write to CloudWatch logs, but by default, CloudWatch logs is set to never expire your data. I can understand why it never does that, because they don't want to delete your data without you saying so, but there is a cost to storage. Compared to ingestion cost, is fairly small, but remember, this is accumulative. So if you're writing 10 terabytes, or I don't know, 10 gigabytes of logs every day, and then over the course of a month, that's going to build up, that go over the course of years, that are going to be building up over and over and over. So, and especially when it comes to logs, the value of those logs messages is going to decrease over time very, very quickly. One more thing to consider, I know the CloudWatch logs is not the easiest thing to use in terms of querying, so many of you are actually shipping your logs to some other third-party services like Datadog, Logs.io, or what have you. And you do that by processing the events in CloudWatch logs, and then maybe using a Lambda function, or go through Kinesis first, and then have Lambda ship those logs elsewhere. But in this case, you're going to still be paying for the processing cost or the ingestion cost at CloudWatch logs. And so because of those vendors will likely also charge you for ingestion, so you're actually now paying twice for processing the same logs, same log messages. And if you're using Lambda and you're primarily trying to get your Lambda logs to this third party, there's a much better way to do that nowadays through Lambda extensions, which is basically a mechanism for you to kind of run like a sidecar process next to your actual Lambda function code that you want to run. And what you have access to at that point is what is called a telemetry API, which allows your Lambda extension to subscribe to events from the main Lambda process. And so you can get information about the logs that's been written and the telemetry metrics and things like that. And you can then use the Lambda extension to ship the logs to the third-party vendor, bypassing CloudWatch logs. At this point, you also want to then add this little bit of a blob to your IAM permissions for the Lambda function so that it doesn't have any permissions to write to CloudWatch logs. There's no like off button that you can say, Lambda, please stop writing any of your logs to CloudWatch. So this is kind of how you do that, because you're using Lambda extensions to ship your logs to that third party already. And if you're looking for a third-party vendor that has got a good login control support and also very cost-efficient, check out Lumigo. They're still my favorite tool when it comes to visibility for my serverless applications. And one more thing I want to mention about the CloudWatch logs as well is those, especially for Lambda, is that you've got these system messages that you get for every single invocation. Even if you don't log anything from your application, you're still going to get those couple of lines when you start, when it finishes, and a report for how much time it took, how much memory was used, and whatnot. For most people, this is probably not an issue. This is quite a small amount of data. But imagine if you're running at scale, like the guys from Fathom, where they're doing billions and billions of Lambda invocations per month. Those system messages can actually amount to a non-trivial amount of money. I mean, for them, $1,000 probably not a big deal, but again, it's just waste. I mean, I don't mind spending money on things, but I want to get some value from what I'm spending money on, and that is not value for money, clearly. So nowadays, luckily, you've got advanced logging controls, which was announced at the last re:Invent. So it's supported by CloudFormation. So when you set up a Lambda function, whether it's with CDK, whatever framework you use, you can set a what is called a function logging config setting, which contains two important things for you to do here. One is the log format, defaults to text, but you can also set it to JSON, so that Lambda will take anything you write to standard out and turn it into a JSON structure, so that for people that are complaining about, oh, my development teams are not writing structured logs, this is kind of like a cheat to get there. It's not great, but it's something at least. But what's important here with regards to the system messages is that once you set this log format to JSON, you can then also use another property called the system log level to say what to do with those system messages that Lambda outputs for every single invocation. And they don't have actual, this is not in the official documentation, so I did some tests myself to figure out which messages are reported at which system log level, so that if you want everything, just leave it a debug. But if you just want to see whenever there's like an unhandled exception, you want to see the error in the CloudWatch logs, then you can set it to warn, in which case all the start and report, none of those messages will be recorded to CloudWatch anymore. So quick shout out to Sandro and Tobias for their new book, CloudWatch books. You can go to cloudwatchbooks.com to get it. So I know CloudWatch is not everyone's favorite, but it's such a fundamental service in AWS that I think even if you don't use it, you should at least learn about it and know what you can do and some of the pitfalls to look out for. Moving on, I want to talk about something I think Luca talked about at the previous session here, which is about right-sizing your Lambda functions. You probably know this already, that with Lambda, you've got a single thing that you can use to control the power and performance and cost for your functions, which is how much memory you allocate. More memory equals more CPU resources, equals more network bandwidth. And all that is going to grow proportionally to the amount of memory you allocate to your function. So this is great. This means that if I've got a function that needs more joules, I can just dial out the amount of power you get by just increasing memory. Very easy way to make your function more performant in terms of if you're doing something CPU intensive. What's not so great is the fact that, well, it's just one setting that you can really easy to get wrong by an order of magnitude. And I want to show you, I want to talk about like a quick lesson, well, maybe not lesson, well, a really hard learned lesson from one of my clients. So this client is doing some kind of video processing thing, and they've got hundreds of Lambda functions in their environment, and 99% of them are running for less than a couple, like $1 per month. But there's one function that was costing them something like $10,000 a month. So that one function is doing video recording, so it needs to run for quite a little bit of time. The team knew that, okay, we can just give it more memory, and that's going to give it more CPU, and therefore you can encode those videos faster. What it didn't think about, or maybe didn't know at the time, was that once you go over 1.8 gig of memory, you don't just have a bigger CPU, more powerful CPU, you have multiple CPUs, which means you have to write your application in a specific way to take advantage of multi-core. And they were doing this with JavaScript, which is running on event loop, which is single core. So, even though they are getting more power with more memory, but outside of, beyond 1.8 gig, they weren't getting anything. So they were basically paying for 10 gig, but only getting the benefit for 1.8 gig. So most of what they were spending was going to waste. Again, I don't mind spending money. I just want to get value back from what I'm spending. And so in this case, for them, it's either, rewrite application so that you're actually going to use multi-core, or reduce the memory allocation to 1.8 gig, and that can solve the problem with the cost they had. So famous quote from Dunham Roof that 97% of the time, we should forget about small efficiencies, but when we find that critical 3%, we should really go in and try to optimize our application, because that's where the return on investment is going to be. As far as the Lambda is concerned, the Remigo's dashboard also shows you the cost, estimated cost for your Lambda function as well. So it's really easy for you to just really quickly sort by cost, and then just find the top maybe 1 or 2 functions that say, okay, all right, that function runs a lot, has a high CPU allocation, and the cost is going up, and so let's optimize those maybe 1 or 2 functions. As for how you actually optimize your function, I think Luke must have gone through this earlier. I think the talks are recorded, so when the recordings are out, please watch his talk again. But ultimately, probably the most popular option to do right-sizing Lambda functions is to, is it me or there's like a banging sound there somewhere? is to use the Lambda power tuning tool so that you can essentially take your Lambda function, use a step function to create multiple versions of it with different memory settings. And then it's going to run a number of invocations against each one of those. So then you can find out as your memory allocation increases, does performance improve and does your cost change, so that you can then pick the memory setting that's going to give you the most bang for your buck. Another thing to consider is to instead of using x86, use ARM architecture instead. Reason for that is because the per millisecond cost for Lambda function running on ARM is 25% cheaper than x86. However, the performance of a function can differ greatly. When this feature was initially announced by AWS, I think the blog post talked about how the ARM functions are 19% more performant, plus 25% cheaper, and so worked out to be like 37% cheaper overall because you spend less time running, also per millisecond cheaper. But when I tested it for some of my functions, it's actually 60% longer, less performant, even though it's 25% cheaper per millisecond, but I'm running for longer, like 60% longer, so overall the cost actually goes up. And depending on your workload, those performance performance behavior can be really different. So make sure that when you consider using ARM, test it against your actual function to see how it behaves on x86 versus ARM. But what this is really good for is that when you are talking to third-party services, not naming any names, Salesforce, that tend to respond in like 5 seconds. I guess that's okay in 2024. But yeah, when you got functions that spend a lot of time just waiting, so you're spending money on idle, I/O time, then the ARM is a really good way for you to just save 25% because I'm not doing anything with the CPU. I'm just waiting for Salesforce to call back. So it's much better to just save money by using ARM instead. And staying with Lambda, this is probably the #1 cardinal sin I see people make when it comes to building their serverless architectures using Lambda functions is to have Lambda-to-Lambda invocations. Of course, there's more nuances to that, so we're going to spend a few minutes on this. First, everything that Lambda does, you basically go to the invoke API. Even internally, that's how the Lambda function is used by API gateway and other services that calls Lambda. You always call the invoke API. And there's an important, parameter here called the invocation type. Request response basically is telling you to invoke the function synchronously. You wait for the function to finish running. You get the response back from that invoke call at that point, along with the output from the function. Or you can say, use the invocation type as event. So this is going to be a find and forget. You got to invoke the function, you get a response back straight away, but the function is running behind the scenes. So when you have asynchronous invocations, this is where things like number of retries, DLQ, all comes out of the box. So you don't need to put like SNS or something or like event bridge in front of Lambda functions to get that built-in retry and DLQ support. You get that out of the box when you just invoke Lambda function asynchronously. We're going to talk more about that in a minute. What I want to tell you here is that synchronous Lambda-to-Lambda function calls is pretty much always guaranteed a bad idea. It's always a sign of bad design. As for like cost, the reason for that is because when that first Lambda function calls the second one synchronously, so it's waiting for that second function to finish running and wait for the output, you are paying for the execution time for the second function twice. The first function is still running, is waiting, not doing anything. The second function is running, you're paying for that as well. So you're paying for the execution time twice, which again is just wasteful. I don't mind spending money, I just want to get value for money, and there must be a good reason for me to spend money on something. If I'm just doing it for the sake of it, then I'm doing something wrong. Another thing to consider is that if you got, say, Lambda function calling another one inside the same service boundary, so it's owned by the same people, probably me owning both functions, there's really no reason for me to separate my business logic across 2 different functions. I mean, that doesn't really buy me anything. I can just as easily get modularity in my code. I can still have that nice loose coupling, separation of concerns just inside my code. By putting everything into a single Lambda function, do everything in that one function. Again, this is one service boundary. You're not talking about, separating responsibility between different teams and processes. No, it's one application, one process, just do everything in one function, because they're called Lambda functions, which is kind of infuriating because it's confusing in a way that we also have Lambda functions in programming languages. So Just because they're called Lambda functions, you don't have to treat them the same way you treat Lambda functions in programming in general. You can have separation, you can have modularity in your code without having that separation in infrastructure as well. Okay, so if Lambda-to-Lambda, synchronous Lambda-to-Lambda calls in the same service boundary is a bad idea, what about if when we cross the service boundary? What if one team says, okay, you want to call my service? Great, here's the Lambda function, please use that. That's even worse idea because now you're creating this tight coupling to implementation detail that you have in your team. So the fact that I'm using Lambda function, the fact that I'm running my function in the EUS1 and I call my Lambda function, I know cats be here. Those are all implementation details that someone, depending on my service, shouldn't have to know. And the fact that if I rename my function to cats be here too, this is going to break the system. That's not what you want. Lambda is the implementation detail. It's not a stable interface to your service. So if you want to share some capabilities with other services, then just give them an API. They can call that API. Your Lambda function can still handle that behind the scenes. That's all good. But Lambda is now an implementation detail that downstream doesn't have to think about. And later on, you may think, okay, well, we started this off with 5 requests per second, but now 2 years later, we're handling 1,000 requests per second regularly. And looking at the cost of Lambda is no longer cost efficient. So let's take that workload and move into container. You use Fargate instead. In this case, there's no breaking change to the customer, to the downstream callers, because they're just talking to your API. They don't know what you're using behind the scenes. They shouldn't care the fact that you're using Lambda or containers. So Lambda is not a system interface. You don't want to use that as a system interface. So that's for synchronous Lambda-to-Lambda calls. What about asynchronous invocations? There are some legit use cases, and one that I've used quite a lot is when you've got, say, like a API function that lets handles user requests to, say, create a new profile, update a profile, which ultimately means writing something to a database. But besides that, which is doing what the customer actually wants, I also want to do something that we want as a team. We want to record some business analytics. We want to maybe track some Facebook pixels so that we have some tracking. And we're going to do some other things called Salesforce, because I love Salesforce. Whatever, right? But those are secondary responsibilities that my customer doesn't care about. So instead of having the customer wait for me to do all of that stuff as well, I'm just going to take all of that, put it into a second function, call it asynchronously, so I get all the retry and DLQ and all of that, but the first function can return to the caller straight away. So I can then improve customer experience in terms of people using my app. But also importantly, that means all the secondary things I'm doing, I now have a more robust error handling because I can have a longer timeout because Salesforce takes forever to respond. We know that already. But also, when there's an error, I get a built-in retries with async Lambda invocations and DLQ support after that as well. But this comes with the assumption that we're talking about two functions, again, within the same service boundary. Essentially, everything we're doing in that second function are things that I would have done in the first function if I didn't care about user experience. So if you're talking about the async Lambda-to-Lambda invocation across service boundaries, again, bad idea, don't do that. Lambda functions are not a service interface. It's not a contract interface for your service. Do not use it like that. Async Lambda function to Lambda function invocation is okay. It really depends on your use case and also what you care about most. A good rule of thumb to have, and one that I use all the time when I'm designing systems, is every component on my architecture must have a purpose. They must have reason to exist. They must have some value, because every single thing on my architecture is another cost that I have to worry about or to think about. Another thing that potentially can cause problems in terms of scaling, in terms of error handling, and whatnot. So for them to exist, they must serve a purpose. Again, I don't mind paying for things. I just want to get value for money. As a counterexample, again, Jack from Fathom has got a really interesting story here where they actually improved the performance for a particular process by taking away, well, what they had was the Lambda function handles a user request, puts something onto a queue, a second function runs to process that asynchronous in the background. They actually found that performance, in terms of end-to-end performance, improved by just doing the thing in that first function So as soon as request comes in, just do the thing. And because they also removed the second function and SQS, they also made a saving of something like $24,000 per year as well. So again, if what you're doing with through the queue is not really adding a lot of value, and then well, take it away. And of course, cost is not the only thing you should be looking at. There are good reasons for you to be putting stuff onto the queue and process it behind the scenes, especially if that thing that you're doing can be, can fail very often, or it's more efficient to process them in a batch and so on. But again, it all goes back to why you're doing it, and everything that on your architecture diagram should have a purpose and for them to exist. So moving on to caching. I love caching. Caching for me is basically a cheat code for building scalable and performant applications. I think behind every successful application, there's like a sensible caching strategy. If you read about pretty much any big systems, there's a lot of information there about caching, about how they do it, how to do it sensibly in that particular environment. And if you are talking about just like a typical serverless API with Route53, CloudFront, API Gateway, Lambda, DynamoDB, very, very common setup, you can do caching at every single layer of this. Of course, you want to do some client-side caching for static assets, configurations, and things like that. But you can also do edge caching for your API responses. So CloudFront is perfect for that. If you're making lots of the same calls to the API to fetch some data that doesn't change very often, then use CloudFront caching to make sure that you don't process or you don't do those work multiple times if you can. But maybe you've got something that's kind of common across some customers. It's kind of maybe CPU intensive, or you're coding Salesforce and you don't want to wait 5 seconds every single time. You can also put that response from Salesforce, put it into a cache so that you've got application level caching for your functions as well. And to do that, you can use something like Elastic Cache so that you can just put those responses into Elastic Cache so different functions can access the same cache. But I love serverless, and from the cost perspective, I love the pay-per-use pricing model, and I really don't want to pay for uptime because most of the time, maybe people are not using my application, and I don't want to be paying for things by uptime. And so nowadays, I actually prefer to use Memento, which gives you, so where Elastic Cache charges you based on uptime, like the size of a node, how long you run it for. Memento gives you pay-per-use pricing, so you only pay for the number of caching operations that you perform as opposed to uptime. And speaking about caching, another thing to think about in terms of caching is your Route53 timeout, sorry, TTO, time to live, not timeout, sorry. Because Route53 charges you based on the number of DNS query that someone makes. And if you use the default TTL, which is about 5 minutes, which means the same user or client or whatever may be making multiple DNS queries across the entire session. And if you've got a domain that are fairly stable, that is not going to change rapidly or regularly, then just slap on a longer TTL so that you reduce the number of queries that Route53 have to handle for you. Again, maybe not something that most of you have to think about, but if you need to operate at scale, you are dealing with lots of user requests, then these small optimizations can actually become really, really big cost savings. Another thing about APIs is, I guess, everyone's favorite topic, calls. So on API Gateway, you can actually enable calls, deal with calls quite easy. You can just enable a setting, and then the API Gateway is going to generate option endpoint for your method, option method for your endpoint. But ultimately, that is still something that you're going to get charged for if someone make a call to your API and it's cross-domain, so they have to make the option call first. So you still pay for it, even if it doesn't really show up in your, say, infrastructure as code. You may think, well, that's easy, just caching, you already talk about that. Unfortunately, with API Gateway, there's actually a long-standing, I don't know if you want to call it a bug or what, but ultimately, if you're using authorization header, then it kind of breaks the generated option method doesn't include the authorization header in the allowed headers list. So it actually breaks the whole caching mechanism. And so there's a good chance that if you look in your actual web traffic, your traffic, and with something like Charles Proxy or something like that, you may see that you're making a lot more calls requests than you expect when you have even when you have caching enabled. So the solution is either to just roll your own option methods, or if you can, just move your API instead of like on a subdomain, which counts as a cross domain, just move into the same domain as your front end, but under the slash subpath instead. So that way it doesn't count as cross origin access when someone makes a call from the browser. All right, talking about more interesting stuff in terms of architecture design. So this is probably the most important skill that you need to have as a solution architect working in the cloud, because every architecture decision you make in the cloud is a buying decision, and AWS is literally this giant candy store. You walk in with 200 different flavors or different things, and oftentimes you can get the same thing done with different options. And unfortunately, picking the wrong service can also be very expensive. Take, for example, you're building some kind of event-driven architecture. You need to send messages from one place to another. There's different options for doing that. And the cost for doing that, say 1 message per second, is you may think, oh, Kinesis is kind of expensive there because you're paying for uptime plus the request count. But when you scale that to, say, 1,000 requests per second for a whole month, then suddenly Kinesis is very, very, very cost efficient, because the uptime cost is there, sure, but the cost per million requests is much lower compared to SNS, EventBridge, and SQS. So always take your throughput requirement into consideration as well. Same goes to API gateway versus ALB. ALB's kind of calculation for cost is kind of complicated, and at low throughput, it's also more expensive because of the uptime element. But at higher throughput, say 1,000 requests per second, suddenly there's just no context. ALB is hands down much, much more cost efficient. So a good rule of thumb to have is that services that charge you based on uptime is going to be way more cost efficient at scale. The good news is that most of you are not running at scale, so you don't have to worry about this. But also, you still have to think about the specific cost dimensions for each service you want to use, because what happens if we say our API is not doing 1 kilobyte per request, it's doing 1 megabyte per request? What do you think this number becomes? Not even funny. Because the bytes process is one of the dimensions that ALB charges you on. So based on that dimension, your cost is going to massively blow up when using ALB compared to something like API gateway, and which you're still paying for the data transfer cost, but is a much smaller component compared to the actual request cost. So last re:Invent, Werner gave us the frugal architect, and he gave us 7 different rules for a frugal architect. And I really like this, particularly these 2, where that says architecting is a series of trade-offs, and that we should pick systems whose cost is going to grow in the same dimension as our business revenue. So I've done quite a few WebSocket-based applications, and I love using the serverless offerings that AWS offers. So I can build WebSockets without having to worry about servers. And they all charge you based on the number of messages you process, but also connection time. So if my application is going to grow, it's going to have more users, and therefore more connection time that I have to pay for, but my revenue doesn't grow with the number of users because I'm not paying for, not all the users are paying users. My revenue grows along the line of actual engagement. The more people actually do stuff on my system, the more likely they become paying customers, and therefore my revenue is going to grow along the lines of the dimension of engagement. So I also want my cost to grow with engagement activities, not just connection time. Someone can be connected for hours without doing anything, and they have no intention, they have no incentive to become a paying customer. Again, I want to bring up Memento, because they also have got this thing called topics, which gives you WebSocket support out of the box, but also they charge you only based on the number of messages you send to the topic and broadcast to the subscribers to the topic, as opposed to connection time. So once again, I want to find services whose cost dimension aligns with my business revenue, the dimension that the business revenue is going to grow. And speaking of picking cost-efficient partners, does everyone remember this? This blew up just a couple of weeks ago. Some social network entirely funded by volunteers went from 0 users to 500,000 daily active users, and then Vercel sent them a $100,000 bill. I guess the good news is that they were able to scale, right? It's very scalable. Bad news is that Vercel has got this massive overage cost because they are building on top of AWS. They are wrapper for AWS, but they also put a wrapper in terms of the cost, the markup, which is fairly significant. They put a 7x markup on the underlying Lambda cost. And so if these guys were actually running on Lambda instead, then it would still be expensive. I mean, if you go from 0 to 500,000 DAU, you expect to pay, but it's just a question of how much is reasonable to pay for that. On top of that, the Vercel introduced a cost now for basically draining your logs from Vercel to some other platform. So looking at the Vercel pricing page, there's just so many different things. So when people complain about AWS pricing being confusing, doesn't even come close to the complexity that Vercel gives you in terms of the different cost dimensions, not to mention the markup they have as well. So I think this is the last one I want to talk about, which is to simplify your architecture. I talked about this already. Everything on your architecture should have a purpose. You should avoid having unnecessary moving parts in the architecture. We talk about how if you got synchronous function to function call in the same service boundary, simplify, put them into one function instead. Much easier, reduce complexity and also cost as well. I also see this a lot. People say, oh, Yan says Lambda-to-Lambda calls are bad, so we should avoid that by sticking an SNS topic between our functions. So we now have an async invocation. But I ask, okay, do you ever plan to fan out? No. The only one that cares about that message is that other function there. We just want to avoid Lambda-to-Lambda function calls because you say it's bad. Well, okay, that's great. You got a gist, but not quite a message. So if you're going to do that, let's just not pretend that this is not an async Lambda-to-Lambda invocation, same coupling effect. By removing SNS from the middle, you actually get the same benefits in terms of async Lambda invocations. You get the same stream retry, the same DLQ support. In fact, you probably make your code a bit simpler as well. Again, I mentioned earlier, async Lambda-to-Lambda invocations, there are some valid use cases for that, but don't use Lambda as the entry point for your service if you're doing like a microservices environment. I want to keep saying this, that every component in your architecture must have a purpose, must give you some reason for having it there. Don't just do it because, well, we always put SNS between Lambda functions. Oh, turns out I've got more. Okay, another move, function URLs. API gateway is great, I love it, but nowadays you don't need it to build a serverless API. If you're not using all the sort of features that API gateway gives you, or maybe you're running into some limitations like, oh, I want to do response streaming because I'm doing AI, I've got LLMs that takes really long time to respond, then API gateway doesn't support response streaming. What you can do is use the Lambda function URLs and write a Lambda lith, which is Lambda function that handles all the different routes for your API. So some limitation to think about in terms of writing Lambda lifts, the fact that you're not going to get fine-grained metrics for individual endpoints and different fine-grained different assets controls for each endpoint. And if you're using some big frameworks, then that can also be expensive in terms of cold start. But it's great for public APIs or public or internal APIs. But turns out, using Lambda function URL with Cognito is also viable. Turns out it's actually really quick to authenticate your token. We can go the other way as well, so that instead of removing API gateway and going function URL, we can actually go the other direction. If I'm just building CRUD stuff, no business logic, just take whatever people send, put into database or whatnot, then I can have API gateway do that for me without writing a Lambda function. And removing Lambda function from architecture means no cold start, and also no cost related to running those Lambda functions. And it goes beyond APIs as well. So if I want to do, okay, someone makes a post request, I want to write some data to DynamDB, and I want to process that event as an event, turn that into an event. I can use the event bridge pipes, transform that data, and send them to event bridge, event bus, and I can use the Lambda function to transform the event into the right payload so that it's no longer speaking database events like insert and update and whatnot. It transforms them into domain events like user created, user updated. A good saying from RJ from way back is that you want to use Lambda functions to transform data, not to transport data. Another very common use case is to take whatever you have in DynamDB and sync it to your OpenSearch. Nowadays, there's the no-code ETL. You can do all of that without writing custom Lambda function. And if you're building APIs, there's also AppSync as well for GraphQL. Workflows, you've got step functions. Again, they can just do all of that, writing stuff to DynamDB and putting stuff into EventBridge for you without you having to write custom code. Again, I'm not against writing Lambda functions. I do that all the time, but everything that I put into my architecture must have a purpose. And Chris is going to talk more about this approach later on this afternoon as well. Oh, okay, one more dangerous move. I want you to just read about it, but don't use it. Is having the client go directly to the system. Instead of having API, Lambda, DynamoDB, just so that someone from the front end can get some data from a database, you can actually just go straight to the source from the front end. Before you call me crazy, you can actually do this safely by having the front end log in, the user log into a Cognito, and then take that Cognito token to a Cognito identity pool, and exchange that with back and get back temporary IAM credentials so that you can allow the front end to talk to the backend resources directly. And you can do this safely by making sure that the Cognito identity pool's authenticated role has got a condition that says only allow this IAM role to access a role in DynamoDB whose partition key matches the subject of the Cognito identity token. So this is how, and you can do the same thing with S3 as well, and this is how you can have the client, the front end, safely access data in the backend without breaking the tenancy boundary. It's not for the faint of heart, and I can think of 100 reasons why you wouldn't want to do this. There's only one reason why you would want to do this, and that one reason is I'm a bit of a cheapskate. Well, no, honestly, it's because I'm bootstrapping a new project, and so I'm paying out of my own pocket. I'm really conscious about cost. I want to do all I can to be optimally to be optimized for cost, and this may be a move that you want to consider, but it's definitely high risk, high reward. I wrote more about this in my blog post later, but you can read about that hopefully once you've had lunch. But yeah, so those are the 12 moves that we talked about today. And I've got some workshops coming up on the building serverless applications. You want to go check it out. That's the website. But yeah, thank you guys so much. I hope you guys enjoy lunch as well. And I'm going to be around for the rest of the afternoon. So feel free to come and grab me and ask questions if you've got any. Okay, thank you.